In this lesson, we're going to cover mid-segments of triangles. When we look at mid-segments of triangles, we can look at them in a coordinate plane. Then we'll also just look at them in diagrams and be able to, just like what we've been doing, be able to solve triangles and various other things as we move forward in this course. So a mid-segment in a triangle is simply a segment that's going to connect the two midpoints of the sides. So that's why it is a mid-segment. It connects the midpoints. And in each triangle, it's going to have three different mid-segments. And when you draw all three of them, it makes another triangle inside. And so this is called our mid-segment triangle. So as you can see in here, we have this triangle that was drawn inside of ABC. And so that's our mid-segment triangle. So when we look at example 1, it asks us to show that the mid-segment MN is parallel to JL and that MN is equal to half of JL. So first let's focus on parallel. When we're looking at a coordinate plane, we should be thinking that parallel, something that we just reviewed over, is whenever we have the same slope. Okay, so if I first look at JL, I can look at the slope. So remember, in a diagram like this, my slope, I can simply count it. So slope is my rise over run. Okay, something to remember. We've already covered this before. So if I want to know the slope of JL, so I'm going to do M of JL. I'm going to start at J, and I'm going to look at my rise, and then I'm going to move over towards L to look at my run as well. So if I start from J and going to L, my rise, it looks like it's going to go down 2. Okay, so that would make that a -2. Then my run is going to be how far it goes across. So it goes 1, 2, 3, 4, 5, 6, 7, 8. You notice this can reduce, so it's going to become -1/4. Then I'm also going to look at my slope of MN. Okay, it said to compare them, see if they're parallel. To be parallel, I would expect them to have the same slope. So if I start at M, to go to N, I go down 1, so that means my rise is a -1. Think about a number line. When I go down, it's negative. And then when I go, my run is 1, 2, 3, 4. So if you notice, they both have a slope of -1/4. So this would tell us that MN is parallel to JL. Okay, so that's my first statement, first thing we were able to prove. So I'm going to erase this stuff. And now the second part, it wants us to be able to show that MN is half of JL. Okay, well, in order to know if it's half of it or not, we need to know how long it is and how long each of those segments is in order to compare it. So to find length of a segment in a coordinate plane, that's when we use our distance formula. Okay, so distance formulas are D equals the square root. So we're going to have x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug it in. Okay, so I'm going to erase this parallel statement for the moment. And I'm going to get started. So if I have my D is equal, I'm going to start first with MN. And I'm going to plug it in. So MN has the points of -4, 2, and N is 0, 2. So I'm going to plug them in, my x1 and my y1. So if I term this one as my x1, y1, that means this one has to be my x2, y2. And then I just substitute. So my x2, I'm going to have a 0 minus my x1 of a -4. Well, -4 is going to make that a +4. Okay, this is distance formula again. We've done this several times. Y2 is my 2 minus my y1 of 2. Oh, no, I'm sorry. This is supposed to be a 3. I miscounted that. So actually, my y1 is going to be a 3. Yeah, I'm just going to change it. So continue to work. 0 plus 4 gives me 4, so I have 4 squared. Plus 2 minus 3 gives me negative 1 squared. I'm going to leave it in the parentheses since it's negative. Then if I continue to simplify this, 4 squared is 16. Negative 1 squared, remember that negative is squared as well, so I have negative 1 times negative 1, which gives me a positive 1. So I end up getting that this is the square root of 17. Okay, right now I'm just going to go ahead and leave it in that format. I can put it in a decimal later if I need to. So I'm going to copy it over here. So I have d of mn is equal to the square root of 17. Now I'm going to continue to find my other distance in order to find out if it's half of that one. So d is going to be equal to, this time I'm doing my distance of JL. So I'm going to use my points of JL. So I'm going to go back. I'm going to erase these other ones. And now I need to label these. So I'm going to have my x1, y1, my x2, y2. Remember, it doesn't matter which one you do as your x1, y1, which one you do as your x2, y2. I just term them so that way I know which ones I was using, so I don't accidentally use one twice. So my x2, I'm going to have 2 minus my x1 of negative 6. So if it's a negative 6 times this negative, it's going to be positive. My y2 is my negative 1 minus my y1 of 1. My squared. Continue to simplify, so 2 plus 6 gives me 8 squared. Negative 1 minus 1 gives me negative 2. Since it's negative, I'm going to leave it in my parentheses. 8 squared gives me 64. Negative 2 squared, remember it's negative 2 times negative 2, which gives me a positive 4. And so this is going to give me the square root of 68. So I can write this one on the side as well. I have d of JL. My distance of JL is the square root of 68. So now that we actually have the distances, remember, we've already proven this first part. Okay, so we already said MN is parallel to JL. Check it off. It's correct. We're looking at the second one, that MN is equal to half of JL. So I'm going to plug it in. If it were to work out and it's equal on both sides, then that means it's a true statement. If it doesn't, then it means it's not actually equal. So if I have MN, okay, when it's capitalized like this, it just means it's the distance of it, is equal to half of JL. So I'm going to plug them in. My MN distance is my square root of 17. Then I have half times my JL distance, square root of 68. Now, if you know how to reduce radicals, you're more than welcome to do that here at this point. We will get into that further on, where we will go over how to simplify a radical. But right now, if you just want to use your approximations by doing square root, so I'm going to put it in my calculator. So for the square root of 17, I get approximately 4. I'm going to do 2 decimals, so 4.12. So then it'll be 1/2 times the square root of 68. And this approximation is going to be about 8.25. If we take half of 8.25, so I'm going to just divide it by 2. If I keep going down to simplify, I get 4.12 approximately, which if you notice, that's 4.12 on the other side, so this checks out as well. So in this example, we were able to show that the midsegment MN is parallel to JL, and the MN is half the length of JL. Okay, so these are going to be 2 properties of a midsegment. In this diagram, MN is our midsegment of our triangle. In this case, our triangle is JKL. And so now we've just looked at that in a midsegment of a triangle, they are always half the length of the whatever side they're parallel to, and they're always parallel to that side. So essentially, it's just the side that it doesn't touch, it doesn't connect. Okay, a midsegment connects 2 sides. Whatever side it doesn't connect, that it doesn't touch, it's going to be parallel to that side, and it's going to be half the length of that side. So if you look at this diagram, I'm going to kind of highlight over some of it. We're talking about this triangle on the outside. It says triangle RST. Okay, it's just the big one going all the way around on this side. It tells us that UV and VW are mid-segments. Okay, so we have one mid-segment here, and we have one mid-segment here. It wants us to know, it wants us to find what their lengths are. Whenever it doesn't have the segment symbol above it, that means the length of that segment. Okay, that just goes back to distance formula at the beginning of the year. If I don't put the line segment above it, it means it's talking about the length of it. So if it wants me to find UV and RS, then we just need to solve for it. So let's first start off with UV. Okay, UV, this mid-segment UV, is parallel with the side RT of the triangle. Okay, whatever side the mid-segment is parallel with, whatever side it doesn't touch, it's going to be half that length. So that would mean that UV is half the length of RT. Right, we agree that UV has to be the smaller one, so it has to be half of RT. So then I can just plug it in. So UV is equal to half RT's length. It tells me in the diagram is 90. So then I just solve. So UV is equal to half of 90, so half of 90 gives me 45. And that would be my answer. I encourage you to pause the video and try to work for RS on your own, because I'm about to do it with you. Okay, so the next one that we're looking for is RS. Okay, RS. RS is a larger side, and it's parallel with this mid-segment of VW, or WV, whichever way you want to say it. So since VW is the smaller one, VW is equal to half the side it's parallel with, the side it doesn't touch, of SR. So then plug it in again. So VW we know is 57. And then we have half of SR. If I want to get SR by itself, then I need to get rid of that 1/2. Right now they're being multiplied, so either I can divide by 1/2 on both sides, or I can this is essentially SR divided by 2, right? So I can multiply by 2 to both sides to get rid of this fraction. So that on the right side I would just have SR, and then I have 2 times 57, which will give me 114. SR is the same thing as RS, so that's my answer, 114. Okay, so this last problem we're going to look at is just a little bit more steps, okay, but it's still just mid-segment of a triangle. Okay, mid-segments are parallel, and they are half the length of the one that's across from it. They cross over at those midpoints as well on the sides of our triangles. So in this diagram, we have Paris Street intersects Cherry Street and Peach Street at their midpoints. Okay, so first thing about if Paris Street is intercepting them at their midpoints, then that means that each side is going to be the same length, right? Paris Street is cutting Cherry Street exactly in half, so each side is going to be the same length. Same thing's going to happen to Peach Street over here. Okay, so Peach Street, let's say, we're going to put 2 lines in a different color over here. It's also cut in half, so the top and the bottom part are going to be exactly the same. And so it tells us in this little scenario here that we're going to run, okay, if you're a jogger, if you're running, or even if you're driving your car, if you're not a jogger and you want to apply this, we're going to go from point P, which is our house. So it says you leave your house, and you're going to jog down Cherry Street all the way to Plum Street. So we're going to start at P, and we're going to go all the way down to Plum Street. Then it says we're going to go over to Pear Street, across Plum Street. We're going to go back up to Peach Street, cross back over to Cherry Street, and then go back to our home. Okay, so we need to find the total length of how far we jogged, how many miles we jogged. Okay, so let's first start looking at the very beginning part. Okay, so here, we start off from just our home all the way down to Plum Street. Okay, how far is that distance going to be? We know that part of it is 1.3. Think about from your home to Pear Street, we know that's 1.3 miles. We also know that Pear Street intersects at the midpoint. Okay, so if it's at the midpoint, then that means that the top part's 1.3, so is the bottom. So that means we first go all the way down to Plum Street. We're going to go 1.3 and 1.3. So together, we're going to have 1.3 and we're going to have 1.3 added up. Then we're going to go across Plum Street. So that's a 1.4. Then we go up only to Pear Street. Okay, the total length of Pear Street is 2.25. If we only go to Peach Street is 2.25. If we only go to Pear Street, we're only going up half the way, right? Because again, it intercepts at midpoint, so it's only going half the length. So half of 2.25, if you need to do it in a calculator, you can. So only half of it is going to be 1.125. Okay, so I'm going to add that one here as well, 1.125. Then I go across Pear Street. Now think about Pear Street. I'm not given the length of it, so how would I find it? Remember, it's a mid-segment, so a mid-segment is always half the length of the segment it's parallel to. So the segment it's parallel with is this bottom one. Okay, remember these are parallel symbols doing the little arrows going in the same direction, same number of arrows. It means they're parallel to each other. So if they're parallel, Pear Street is going to be half that length. So if I do, I'm going to say Pear is equal to half the length of Plum. So half of Plum, so we have 1/2 times 1.4 would be equal to our Pear Street over there. Half of 1.4, which is going to give us 0.7 or 0.7. So it means I'm going to add that part in as well. And then I go back to my house from there. So that part is going to be this 1.3 again. So we add this all up. You can do it in a calculator or you can add it all up here. We have our 2.5 is going to carry down. We have 3 and 7 make 10. We have 3 and 3 make 6. 4 and 1 make 5. So I have 5 plus 6 makes 11. Plus my 10 gives me 21. Carry it. I have 2, 3, 4, 5, 6, 7. So my total miles jogged, and it doesn't tell me what decimal, is going to be about 7.125 miles. Okay? It's a pretty long jog. It's not too bad, right? If you're able to write down at the end of your notes today that 7.125 is not that bad, right? I mean, I can't do it. Okay, but I will tell you that my husband, he's training for a half marathon, and yesterday he ran 11 miles. Okay, so if you're able to write that on your notes, don't tell your friends, then I will give you bonus points. Okay, I'm going to give you an extra 300 tomorrow.